Alright, day 12. This is Algebra 1, day 12. We're looking at lesson number 9. So go ahead and make sure you have day 12 workout lesson number 9. We're going to be talking about multiplying polynomials. So let's go ahead and dive right into this lesson. One thing you want to know is our goal for today is so that you understand that the product of two polynomials produces another polynomial. You've got to be able to multiply polynomials. Alright, so exercise number 1. Giselle computed 342 times 23 as follows. Pay attention to what she did here. Can you explain what she is doing? What is her final answer? Well, this should be something that looks familiar to you. We've used these. What did she use here? She is using an area model. She is using an area model here. She is finding the area of each rectangle and then adding them together. Alright? She is making sure she's finding each area of each rectangle, and then she's going to add them together. So it wants to know, what is her final answer? Well, if I add all of this together, her final answer is 7,866. And if I actually were to pull out a calculator and multiply 342 times 23, look at my answer, 7,866. Using a geometric diagram to compute, use a geometric diagram to compute the following products. All right. So you can do a couple of different things here. Geometric diagram is basically just like this area model. So they want us to draw an area model to figure this out. So look, I've got a 3 by 2. Alright, so I can do 3 across. I can do 3 on the side, which I think I'm going to do that just to give myself a little bit more room. So I'll do 2x at the top and 3 here. I'll do 3x squared, 4x, and 2. Alright, and now we multiply. 3 times 3x squared is 9x squared. 2x times 3x squared is 6x cubed. 3 times 4x is 12x. 2x times 4x is 8x squared. 3 times 2 is 6. And 2x times 2 is 4x. And now I can add those together. Alright, so here I've got my diagonal here, that's 6. And guys, this is just a matter of adding together like numbers. So 4x and 12x can be added together. 8x squared and 9x squared gives me 17x squared. And then I have 6x cubed. I cannot combine any more, so my answer would be 6x cubed plus 17x squared plus 16x plus 6. And that's my answer. You're going to see a lot of this in Algebra 2. So make sure you understand this. All right, let's look at the next one. I have 2x squared plus 10x plus 1 and x squared plus x plus 1. This is a 3 by 3. Draw my box here. So I have 2x squared at the top, 10x, and 1. I have x squared, and x, and 1. Alright, now I do my multiplication. So 2x squared times x squared is 2x to the 4th. 10x times x squared is 10x cubed. And 1 times x squared is x squared. Multiply 2x squared times x is 2x cubed. 10x times x is 10x squared. 1 times x is x. 2x squared times 1 is 2x squared. 10x times 1 is 10x. And 1 times 1 is 1. Now I'm going to combine my like terms. Guys, pay attention to your diagonals. And when I talk about diagonals, let me get a highlighter because I want you to be able to see this. I found that if I actually highlight it, it makes it a lot easier for you to see. So look at this. Let me highlight my diagonals. Look at what happens on my diagonals. My diagonals actually line up everything that I can combine. The only thing in this diagonal is 1. Here I've got 10x and 1x. That's 11x. 2x squared, 10x squared, and x squared. Well, 2 plus 10 is 12, plus 1 is 13x squared. 2x cubed and 10x cubed gives me 12x cubed. And then 2x to the 4th is the only thing there. So now I have combined everything that I can. Here's my answer. 2x to the 4th plus 12x cubed plus 13x squared plus 11x plus 1. And I'm finished. Because I cannot combine anything else to do. Alright, let's look at the last one here. Alright, I have x minus 1 times x cubed plus 6x squared minus 5. Alright, now let me show you something here. I want you to pay attention to this part right here. The x cubed plus 6x squared minus 5. If I look at my polynomial and I look at the degrees that I have something to the 3rd power, the 2nd power, but I don't have anything to the 1st power. Let me tell you a little secret, because this will help you in figuring out how to make this line up correctly. Because I do not have anything to the 1st power of x, I need to put that in there. So I want to rewrite this polynomial as x cubed plus 6x squared plus 0x minus 5. If I add a 0x in there, it does not change the value of anything. Because 0 is nothing. It does not change the value. But this is going to help me because this will allow my diagonals to line up correctly. Alright, so now I'm going to draw. I've got a 4 by 2. so I have x cubed, 6x squared. I have that 0x and negative 5. And then I have x minus 1. All right, multiply. X cubed times x is x to the 4th. 6x squared times x is 6x cubed. 0x times x is 0x squared. And negative 5 times x is negative 5x. All right? X cubed times negative 1 is negative x cubed. 6x squared times negative 1 is negative 6x squared. 0x times negative 1 is 0x. And negative 5 times negative 1 is 5. All right. Notice, I'm going to look at my diagonals here. It should have everything lined up for me. Now I can combine my like terms. I've got 5. Negative 5x and 0x is negative 5x. Negative 6x squared and 0x squared is negative 6x squared. 6x cubed and negative x cubed. So 6 minus 1 is 5x cubed. And then x to the 4th. So now I can write my answer. X to the 4th plus 5x cubed minus 6x squared minus 5x plus 5. Okay? And there's my answer. Now, can I do this without a geometric model? Can I multiply all of these without using this box? I can. I like this box because I think it helps. It helps me to line everything up. But I can multiply these without a geometric model. All right? So, what's that called if I do this without using a geometric model? Well, let's look at this. If I wanted to, and I'm just going to rewrite this problem here, and I'm going to go back to the original problem. If I wanted to multiply this without using my box, forget the box here. I want to multiply it. Guys, I would use what we call the distributive property. You guys should know what the distributive property is by now. Which means I'm going to multiply x times everything inside that parentheses. Then I have to multiply the negative 1 times everything inside that parentheses. When I do that, then I have to combine my like terms, and then I would come up with the same answer. Let's look at exercise number 2, because exercise number 2 wants us to multiply the polynomials using the distributive property. All right, so we're going to multiply 3x squared times x to the 4th, which gives me 3x to the 6th. X to the 4th times x to the x squared is x to the 6th. I'm just adding my exponents. All right. 3x squared times negative 2x is negative 6x cubed. 3x squared times 1 is 3x squared. Now I have to multiply the x. So x times x to the 4th is x to the 5th. X times negative 2x is negative 2x squared. And x times 1 is 1x, or x. All right, now I've got to do the negative 1. So negative 1 times x to the 4th is negative x to the 4th. negative 1 times negative 2x is a positive 2x. And negative 1 times 1 is negative 1. Now, once again, I like the geometric model because it helps me to line everything up. If you miss a step using the distributive property, your answer is going to be wrong. So you've got to be very, very careful in making sure that you are multiplying everything. Now that I've multiplied, I have to combine my like terms. All right, so I've got 3x to the 6th. I don't have anything else to the x to the 6th. All right, I'm going to look for x to the 5th. So I've got 1x to the 5th. And I like to mark them out as I go. That way I know I'm getting everything. Do I have any x to the 4ths? I do. I've got a negative x to the 4th. Let's look at my x cubes. I've got negative 6x cubed. Now I'm going to look at my x squared. So I have 3x squared and negative 2x squared, which gives me 1x squared. Now I'm going to look at just my x to the first powers. So I have 1 plus 2 is 3. And then any number that doesn't have an x is a negative 1. So there's my answer. This one takes a little bit more time because honestly, you have to be very careful about your steps. Making sure that you are doing every step that you have to do. All right, let's look at exercise number 3. The expression 10x squared plus 6x cubed is the result of applying the distributive property to the expression 2x squared times 5 plus 3x. It is also the result of applying the distributive property to 2 times 5x squared plus 3x cubed, or to x times 10x plus 6x squared. For example, or even to 1 times 10x squared plus 6x cubed. All right, so for 1 through 10, you're going to write down an expression such that you apply the distributive property to your expression. It will give the result produced. Give interesting answers. All right, so let's look at this. I've got 6a plus 14a squared. In this case, what I want you to do is I want you to figure out what is something I can pull out of this problem. Well, they both have a's in common, so I could pull out an a and say, okay, I've got 6 left, and then I have 14a. So if I actually were to use the distributive property here, a times 6 would give me 6a, and a times 14a would give me 14a squared. So I'm doing the reverse distributive property here. All right? Another way that I could have done this, I could have pulled out a 2 and said, okay, well, 2 goes into 6a 3a times, 2 goes into 14a squared, 7a squared times. So if I come back here and I do the distributive property again, I'm going to see that I would get my 6a plus 14a squared. All right? Number 2. Guys, I can do it this way. Look, I've got a 2 in common. I've got x to the 4th in common because everything else is bigger than x to the 4th. So I could pull that 2 out and get x to the 4th plus x to the 5th plus x to the 10th. I could pull x to the 4th out and get 2. There shouldn't be anything else there. I get 2 plus 2x plus 2x to the 6th. Okay? So just some things that you can do there. How can can you pull out? What can you pull out here? All right. 6z cubed, or 6z squared minus 15z, I can pull out 3. And I get 2z squared minus 5z. All right. What I would like for you to do is, I'm not going to spend time going through the video doing this. What I would like for you to do is, I would like for you to finish this. We're going to say this is homework. I would like for you to finish these, and then I will check them when you turn in your packets. All right, let's go to exercise number 4. All right, exercise number 4 says this. Sammy wrote a polynomial using only one variable, x, of degree 3. Maisha wrote a polynomial in the same variable of degree 5. What can you say about the degree of the product of Sammy's and Maisha's polynomials? Well, first of all, I need to make sense of what it's telling me. So it's telling me that Sammy wrote a polynomial using a variable x to the degree of 3. So he wrote x cubed. Maisha wrote a polynomial with the same variable with a degree of 5, so she wrote x to the 5th. It wants to know, what can you say about the degree of the product? Product means to multiply, so it wants me to multiply x cubed and x to the 5th. Remember, when I'm multiplying same bases, I'm simply going to add my exponents. So the degree would be 8. The degree of the product would be 8. That when multiplied by 2x squared plus 3x plus 1 gives the answer 2x cubed plus x squared minus 2x minus 1. What would I do here? This is actually an extension. And it is actually an introduction to something that we do in Algebra 2. I would like for you to see if you could come up with something here. And then write it down. Try for me. And then what I'll do is I will look at these, and I'm curious to see how you go about figuring this out. All right? So, you've got to finish the 10 problems that we started, and you need to finish this extension. All right? Guys, if you need help, ask.